Hello. In this video, we introduce the between effects models in panel data analysis, which are used to analyze time-invariant variables. We demonstrate this step by step using our own panel dataset. The regression results of which were reported in our article, published in 2025, in Organizational Cultures, an international journal. Panel data, also known as longitudinal or cross-sectional time series data, is a dataset in which the behaviors of entities are observed across time. To gain a foundational understanding of panel data, please refer to our previous video, titled What is Panel Data and Panel Data Analysis Method. In this video, we will demonstrate how to perform a between effects regression, using our panel dataset, which includes 750-year observations, across 79 countries, over the period 2006 to 2019. Our research aims to examine the impact of national culture on country-level entrepreneurship. The data for this analysis were collected from the Global Entrepreneurship Index reports, Hofstede Insights, and the World Bank's Open Database. In our dataset, because of collinearity, 6 time-invariant cultural variables are omitted in fixed effects model, so, we must use the between effects model instead of fixed effects one. The between effects model is a panel data estimator that focuses on cross-sectional variation by averaging observations over time for each entity. Unlike the fixed effects model, which captures within entity variation in term of time series, the between effects model emphasizes differences across entities. This approach is particularly useful when the primary interest lies in explaining how long-term, structural differences between units, such as countries, affect the dependent variable. By leveraging only the between-entity variation, the model provides a broader view of persistent differences that are not driven by short-term fluctuations. The between effects model rests on several key assumptions. First, it assumes strict exogeneity of the regressors, with respect to the averaged error term across time. Second, it presumes no correlation between the entity-specific effects and the explanatory variables. This assumption is similar to that of the random effects model, and distinguishes it from the fixed effects model. Additionally, the model assumes that errors are homoskedastic and not serially correlated across time, though robust standard errors can be used to relax this assumption. Violation of these assumptions can lead to biased and inconsistent estimates. The equation for the between effects model is in the screen. The between effects model is appropriate when the variation of interest lies primarily between units rather than within them, and when the panel has sufficient time-invariant characteristics that are meaningful for explaining the outcome. It is also useful when the within-unit variation is limited, or when the explanatory variables are largely constant over time. Now, we perform the between effects regression model using our panel dataset. Before running the model, it is necessary to declare the panel structure in Stata using the command xtset. To handle panel data, click on Stata's menu as shown here. In this case, ID represents the entities, that is countries, and year represents the time variable. Or, you can type the command here and enter. Note that Stata distinguishes capital letters, so you must type exactly the variable name. As the panel data has been handled, we can now run the between effects model, using the Stata command xtreg, with dependent variable GEI and 8 independent variables. Type the command here. Note that, the option B should be chosen for the between effects model. Or, you can click this command on the Stata's menu for avoiding typing errors. The regression results can be used to test the research hypotheses. However, it is essential to ensure that the between effects model is appropriate for your dataset, based on a model selection process that considers the between effects, random effects, and pooled OLS models. We finish here the presentation. Thanks for your views and subscription to our channel. And see you in the next video.